Good morning, good afternoon, good evening. Welcome to our EIG's fourth in a series of webinars focused on using AI ML strategies to accelerate your root cause analysis kickoff meetings. Today, we're very excited to have a live demo of the tool solving real life RCA events, and not just one, but three different scenarios we're going through. And with our guest speakers, we have Parr, founder of InRoute.io, and Dr. Irene Legic, founder and CEO of IALS Consulting. And my name is Jim DeVries from Enhance International Group. We appreciate you taking the time to join us today and building that evolving, resilient enterprise. This is the fourth in the series of webinars. Our webinars are on the EIG website. We start out with capitalize on your mistakes, empowering root cause analysis to prevent future losses. Then we went into unlock employee engagement in RCAs, proven methods to slash risk events. And then we got into digital tools, getting introduced to the digital tools. And today we're going to have that live demo, finally, that you all been waiting for on using AI and ML to help us solve these root cause analysis in a speedy and effective way. Future webinars that we're looking to work with some of our partners, Pharos Labs and DSS, DuPont Sustainable Solutions. With that, we want to just do a brief intro on Irene. Irene has earned her doctorate of chemical engineering from Rutgers, and ILS Consulting guides manufacturing and engineering organizations to lead their sectors. And of course, we have Aaron, our star here on InRoute.io, who is a dedicated chemical engineer, Lean Six Sigma black belt, and passionate about process optimization and problem solving. And he's built this InRoute.io product that we're all anxious to see in action. With that, the deliverables of today's webinar are addressing challenges to applying AI to RCA events. What are those challenges? And then getting into the architecture that Aaron has developed. And then we'll get into some, what are the key tools that will be demonstrated throughout the three case studies. And we'll get into the technology roadmap that Aaron has developed to get there, and then integrate it into how do we integrate that into your daily work patterns of addressing root cause analysis. And as it says at the bottom, an unplanned downtime, a symptom of a deeper issues you're overlooking. So unplanned downtime is not what you want to be running your company. With that, we have Irene to kick us off to give us an overview on our company. Irene?
So, hello, everyone. Improvement and Lean Services, or ILS Consulting. I work with small to mid-sized companies to help them drive operational excellence, continuous improvement, as well as engineering operations and optimization. I have a Six Sigma black belt degree or certification, which I can use to be the rent a director or rent a person to help you with starting continuous improvement programs, hands-on guidance, as well as program management. We try to shine the light on opportunities to drive business success. Thank you.
All right, and hello and good morning, everybody. My name is Parr. I'm a chemical engineer and Lean Six Sigma black belt. I've spent most of my career working in the sustainable energy technologies, using statistical process control, statistical design, and statistical optimization of those systems. Before leaving the corporate world to start InRoute.io, overall, our mission at InRoute is to help teams minimize the time between incident occurrence and resolution with human-in-the-loop RCA systems, most of which are infused with AI or machine learning algorithms. Ultimately, our vision is to create an end-to-end system that will detect and resolve root causes down to root causes in real time, which will help empower teams to achieve unparalleled speed and precision. We are doing this in a two-pronged approach. First, and this will be much of the focus today, we're building this engine custom for enterprises where much of the capabilities that we're going to go into the case studies are actually already available today. They just need to be customized to your specific organization. And then two, we're building out a generic self-service version of these features and capabilities in phases. And this will apply for everybody from startups to small and medium-sized businesses, hopefully enabling all of those teams to build a robust incident management program. And we actually just launched our first self-service module last week. So really excited to get into some of that today.
Fantastic, Aaron. Congratulations on your launch.
Thank you.
With that, that just gives you an inkling of two of our excellent partners in EIG. We have over 70 partners in our group, and we provide SaaS solutions, people, process, data solutions to your company to be able to provide you that overall solution through our multiple vendors or providers, and creating that 1 + 1 + 1 = infinity to solve your problems for the last time. Today, of course, we're focused on how do we drive that visibility to risk to create action, and Aaron's enroute.io is an excellent tool to help us out with that. So with that, let's start with my old friend of mine, so to speak, is Deming, and us Lean Six Sigma Master Black Belts. We look at him as the father of Lean Six Sigma, and one of his main things that he always emphasized, he had his 14 tenets and 4 areas that he focused on, and the focus is you have to appreciate a system. So a bad system will beat a good person every time. So what we're doing here with Aaron is we're building a good system for the last time to solve your root cause analysis events and get to those root causes and solve them for the last time and really increase your productivity, your uptime of your facilities. So very exciting what Aaron has put together, and it aligns perfectly with Deming postulated all those years. With that, we'll get through the agenda here. We're going to do the challenges of conducting RCFA, root cause failure analysis of events. We'll look at the tools through the en-route perspective, putting your glasses on, this looking at the tool itself. Then we're going to cover 3 different case studies. First, a generic turbine generator trip, close to my heart since I'm a turbine generator guy going back in my first career, or one of my careers. Application 2 is a generic spill of high toxic material or fire from the spill of solvents involving environmental health safety. And that's one that in a chemical plant or in a refinery, very common challenge for us. And then our third is cybersecurity, and that's one that affects us all every day. And Aaron will show how his tool can actually help in these 3 different environments. That gives you the breadth of the strength of this en-route tool. And then we're going to close it out with how to launch with impact to your business. So what do you need to say to your management to sell en-route to them on why you need to get to solve problems faster than you ever have been before. With that, I turn it over to Irene.
Thank you, Jim. So if you think about conducting these RCFA events, a lot of times we're doing this without automation. It gets unwieldy, it takes a lot of time. And so automation really is going to help make sense in gathering the data and driving this in a crisper fashion. However, there are some challenges in automating these events. One of the questions is, well, how do we incorporate that human feedback into it? It's not just data analysis, but there's a very human side and a human observation. component of it. How do we make sure that what people are thinking gets instant visibility? There is some pre-work that has to happen in terms of some time to take to set up the data collection systems in your existing system, as well as transposing that raw data into something that is meaningful. We do have a workforce that is not skilled on how to use digital tools, so there's going to be a lot of training involved. And then, are you collecting the right data? And are you going into analysis paralysis with looking at too much data, but not anything practical? You always have to make sure that you don't have any transcription errors in the process. What was written down versus what was put in the computer, are they the same? You have to make sure that what you're measuring is true. Have you run a measurement system analysis on the data collection? And one of the things that is really concerning or gives you pause for concern is that right now, according to McKinsey, only 11% of AI solutions were scaled successfully in 2024. So in order to do this, we really have to meet a lot of these challenges head on.
Thanks, Irene. And with that, we're going to move to the next section on the in-root IO root cause analysis tool review. And I think we're going to go right back to Irene here to give us the problem to be solved. Irene.
Okay, so we do know that with an incident, we've all have experienced this where we're stabilizing the situation. We need to hurry up and identify the root cause, but it still is a slow and complex and sometimes inconclusive process. So, it's going to be time consuming. These things can stretch out for weeks, especially as you're gathering teams, if you're waiting on metallurgy data. How do we make sure that we're analyzing and connecting data across teams that might be in physically different locations? How do we make sure that there's a centralized place to do so? We got to make sure that our insights and conclusions are reliable. And you got to make sure that, you need to understand, has this reoccurred? Has this occurred 3 years ago? Do we have information from that? And then the other thing too is there is quite a bit of subjectivity in the decision-making process. So it gets to be difficult. And so you need a solution that simplifies this process, accelerates it, helps with that data analysis and integration, and gives you the tools to prevent the problems versus just being reactive.
Thank you, Irene. So we've spent a lot of time talking about what problems exist today in RCA and what additional problems we create in RCA as we try to move away from pencil and paper and we begin to digitize a lot of our business processes like RCA. So let's start by stepping into the heart of the current capabilities at enroute.io. And we're going to start by tying them to each of the to 4 problems that Irene previously covered. So 1, you're in the midst of an incident and it's chaotic because workflows are disorganized and visibility is lacking at all levels of your organization. And to tackle that, we've built a real-time visual task management system modeled on an old Lean Six Sigma tool, the Kanban board. Each RCA becomes a collaborative workspace where every task is laid out clearly, giving teams the agility they need from the get-go. Now, second, we all know that unclear processes breed disorganization. And that's why we've standardized the RCA preparation workflow by prompting users to input consistent critical information directly on the board. We ensure every investigation starts with that same clear foundation. So third, independent investigations can fragment our insights. So our solution to that, seamless team collaboration through interactive polling. That's going to help you gather diverse viewpoints and integrate them directly into your RCA preparation. And polling is not just about collecting opinions. It's about weaving them into your RCA analysis for a more holistic understanding of the problem. And then finally, I want to address one of the most common pain points, which is wasted time due to meeting unpreparedness. Even outside of RCA, I'm sure we've all sat down in a meeting and it's like, what are we really doing here? So our meeting readiness index helps provide a visual snapshot of all tasks and their completion status, ensuring that every RCA meeting kicks off with full clarity on where things stand. And this approach is all about trying to streamline the process so that when challenges hit, your team is ready to respond swiftly when it matters most, like when a part of your process is down. So now let's change gears and explore how AI and machine learning supercharges that analysis. So our tool leverages advanced large language models alongside a proprietary workflow that employs targeted prompts and chunking techniques to distill complex issues down into clear, actionable insights that you can use in your root cause analysis. Now, how are these large language model techniques different from something like ChatGPT? One, we can use the best model for each individual case. We can stack multiple smaller models on top of each other. We can do things like put one model in charge of a task and then have other models check its work, as well as have a subject matter expert check its work, which is very important and I will get to later in the presentation. So imagine starting with imagine starting with an improved and clarified problem statement that immediately sets the stage. So our system dives into a comprehensive 5W2H analysis, which is going to cover the who, what, when, where, why, how, and how much. This helps ensure that nothing is overlooked when you begin scoping an incident. Next, we further refine the process with an is not analysis. And this is going to offer a structured way to compare and contrast the factors at play while you continue to scope your problem further. Alongside this, the tool provides concrete recommendations for data collection, which is going to help ground your analysis in reality. And I will actually get into that in depth in our second case study. And then visually, you'll receive an initial draft of a fishbone diagram, which I'll call trigger diagrams throughout this presentation that maps potential causes. So at the same time, a custom RCA agenda will help ensure that your first kickoff meeting has structure to it and everybody knows their role going into that meeting. We also use AI to perform sentiment analysis on poll responses, which we'll cover briefly in one of our case studies, which helps you synthesize those insights from just gathering things like interviews and going on Gimba. So together, all of these capabilities will help create a robust integrated view that will really go from the journey of transforming raw data into a strategic RCA roadmap and help you uncover the real root causes with both speed and precision while only using your subject matter experts in a limited manner when it's important to have them getting the unit back up online if that's the type of RCA that we're talking about. So let's take a closer look at the core building blocks behind our approach. So imagine that before your RCA meeting even begins, much of the legwork is already handled through automated pre-work. Your RCA tasks are set up and organized so your team can hit the ground running. The second an incident is triggered, these automations will kick off. Then think about how subtle biases can skew our understanding. This happens even out on the shop floor or in a conference room, but especially as we try to communicate asynchronously with digital tools like email or Zoom. We've certainly all seen misunderstandings happen just trying to email back and forth. So with AI-powered bias detection, you can create a system that actively identifies these hidden influences, ensuring that the insights you gather are as objective as they are actionable. Now, third, consider the challenge of gathering data in a structured manner, especially if you're not familiar with the plant or the system you're intending to collect data on. Our data collection plan lays out a clear roadmap, helping guide your teams on what data to collect and when, so nothing critical is left behind. And then finally, objective polling. You can use this to get a clear, quantifiable feedback from your team. This is not collecting opinions. It's about getting unbiased input from your subject matter experts and then feeding that directly into your RCA process, especially when those same subject matter experts, their main focus should be getting that unit up online or addressing the problem, depending on what type of incident it is, right? They could be 100% focused on containment strategies. So each of these capabilities isn't just about having separate features. They're strategic enablers that work together to streamline your RCA process. So in this slide, we'll see exactly how these elements fit into your larger RCA framework, and explore how future phases will continue to build on these foundations. And again, I'm really trying to share a scalable approach to AI and RCA and how you can use that to solve complex issues with speed and precision. So please, if you have any questions as I go through these methods in more detail, ask away. I'd be happy to answer any questions. So let's bring it all together with a look at our integrated RCA workflow process. This diagram is essentially a roadmap that shows not only where our current capabilities plug in, but also hints at a couple exciting enhancements we are planning for future development. Again, our mission at enroute.io is to develop an end-to-end RCA engine. So we really want to be there from the start of an incident all the way to closing out any remaining action items to prevent reoccurrence. So starting at the top, this process begins with informing agencies and leaders, laying the foundation for transparent communication. Even though this stage isn't directly impacted by our current tools, we do have the hopes to use large language models to quickly essentially create a summary for leadership to be able to explain what the incident is in a appropriate fashion for it being super early on in an incident. So next, we establish the team and gather facts. Here, our automated pre-work and objective polling kick in. So this will jumpstart your data collection by organizing tasks, gathering unbiased team feedback through polling. Looking ahead, future phases will incorporate AI-powered data cleansing to refine these facts even further. I see this as a major focus for organizations in 2026. Following up on 2025 being the year to roll out AI agents, I think there's a huge opportunity for improving the quality of data, especially as agents are actually going out and starting to collect data through things like polling your subject matter experts. And then moving on to goal setting and crafting your problem statement, our data collection plan and agenda ensures that the critical details are laid out in a structured way, setting the stage for a focused investigation, and it can be a process that your employees are familiar with. It's the same every time. Then, as we organize our facts, AI-powered bias detection or sentiment analysis will take center stage. This is going to help us sift through the data to identify and eliminate hidden biases so that the analysis remains objective. Again, super important when you begin communicating through asynchronous tools like email and including that in your analysis. And then when it comes to the core of the process, conducting the actual root cause analysis, we currently offer a collaborative workspace that helps unite teams as you build out your problem statement, identify causal factors. In the near future, this will be bolstered by tools like a fault tree or 5Whys AI builder, offering a deeper systemic analysis. If you can picture either building a causal tree, a fault tree, or even like filling out a HAZOP table, if you're familiar with them, you know that there's concrete rules to stepping through those. Large language models are really, really good at following rules. So you can, but they're not always good at getting things right or that human perspective. So combining that human perspective while building a causal tree, but having
So, Aaron,
that
we have a question that just came in.
LLM there to help guide people through the rules is going to be super impactful.
So,
Yeah,
Aaron,
absolutely.
if I can interrupt. Yeah, we have a question that says, what is the process that enroute.io follows to get a company launched onto the tool?
Yeah, absolutely. So we will go through that actually at the end of this presentation. So I won't give a very long answer. We've got a full slide kind of detailing step by step what that looks like. But really what it's going to cover is a feasibility analysis, tying it to an ROI, pilot optimization, and then scaling it across your organization in a concrete way. And I'll get into the details later in that presentation or later in this presentation.
Another question just came in. Once you have data, does the tool have capability to analyze the data or the capability to export into tools like Minitab?
Yes. So if you recall, kind of early on, we're going through a two-pronged approach. So for the enterprise custom version, yes, data analysis is partially automated. It is able to be exported. Um, in the generic tool, that will be in a later module. So our hope is that we will be able to get to the point where there is a self-service version of that, but right now it's only through our enterprise offering, where you can connect to those data sources, run the data analysis, and then ultimately export it to a tool to further your data analysis in something like Minitab or JMP.
Thank you.
So, yep, thank you. Thank you for the questions. Yeah, please keep them coming. So moving into developing corrective actions, this is where creative problem solving happens. And although we don't have a current tool here, our future roadmap includes a brainstorm agent, which will help generate these countermeasures effectively. Then assigning actions is crucial for accountability. When we did our initial customer interviews, right off of planning and setting up an RCA quickly while we were still worried about the actual incident and containment was the top priority. But that was followed number two by how do we actually follow through on our action plan? So while this is an area for future phases, we're planning robust control plan design and an expert system, essentially our smart RCA database to support data-driven decision making and ensure that our actions are clearly delineated. And then finally, the cycle wraps up with reporting and follow up. So our vision for the future is essentially a smart companion, and that's that step past agentic AI, right? Agentic AI, you can hand a goal and it will go and autonomously try and solve that. And this year is kind of like how big of a goal can we give it? Next year, I really see that it going and gathering data and intelligently processing that data and using it to improve its own LLMs through maybe like reinforcement training. I won't get into the technicalities, but that type of cycle is really what I see for that smart companion, where it continuously monitors and cycles through improvements, ensuring that the insights that we gain today keep evolving for tomorrow and getting better and better. So this holistic view not only illustrates how our tools streamline the process today, but also how our plan development will continue to empower your teams to uncover, again, root causes with speed and precision.
Thanks, Aaron.
Thank
And
you.
Aaron has graciously allowed me to present this slide for him on RCA examples. And this is a fantastic way to look at the workflow process from event data, team input, and systems insights. So first of all, for like a forced outage, you're looking at the nature of the event. Obviously, this is a disruptive event. And the analysis kickoffs prompts the 5W2H that Aaron had brought up earlier to frame the problem. And a data collection plan is automatically developed off the logs of the data that's being fed through the system. Then from a team input perspective, you're gathering team expertise through the use of polls and gathering insights and employing sentiment analysis for those folks to make sure that you're really getting to the root cause and that the team is aligned, because the team is generally disparate, and we want to make sure that there's no blind spots in any of the input. And then from a systems insight perspective, we're we're working on meeting this readiness index, visualize fish bones, diagram drafts of immediate action planning. So we're for this overall outcome to set the stage for immediate and actionable planning. So that's one scenario. The next scenario is operating RCAs. And in this scenario, your event context is going on processes encountering bottlenecks. So the data focus is identifying critical data choke points and utilizing the is or is not method to refine the scope of the problem, and looking at From a team perspective, the customization of the agenda and the RCA sessions, making sure that they're pertinent for the task at hand, and integrating poll responses into the analysis. And then, of course, from a systems perspective, tracking this via boards and RCA boards for readiness and operational alignment to get the unit back up and running, if that's the case, or if you're at reduced load, get it back up to full operations. Then the last scenario here is intrinsic issues. And this is, of course, really relying on historical data and looking at what was recommended before, what was working, what's not working, and monitors normalize deviations. And again, the team is getting the team aligned on those sources of root causes, digging deeper into those root causes. Generally, we're looking at effects or high-level root causes. We're really not asking the 5 whys deep enough into the root causal tree, making sure that all the opinions are heard through sentiment. And then from a systems insights, those insights for preventing that reoccurrence. How do we prevent that from occurring? And custom preparation checklists for long-term issue resolution. So how do we make this as a robust system as possible so that you have seamless blending of automated event data, structured team input, and robust system insights? This empowers teams to move from reactive fixes to proactive strategies. And number 3, enroute.io drives RCA success by reducing downtime and improving operational outcomes. With that, we'll go into the architecture. Aaron?
Thank you, Jim. So this RCA system architecture is really today our enterprise offering. Our hope again is that once we release enough phases of the generic self-service for smaller businesses, that this type of structure will naturally present itself. But the key to that really is that connection to the existing data architecture of your business. So with that, let's bring our RCA tool review to a close by kind of zooming out and looking at the bigger picture, how our end-to-end RCA engine fits into an enterprise's data fabric. So in every organization, you're inundated with data from a myriad of sources. Coming from someone whose job it was to go run statistics on these data sources, a lot of my time was going and getting the data. Structured data from ERP systems, IoT devices, maintenance logs, alongside unstructured data like emails, reports, and even videos. That the recent Gen AI hype has actually greatly improved our ability to process stuff like that as typical structured data. The challenge has always been transforming this raw, disparate information into actionable things that actually drive clear, confident, data-driven decision making. So our system architecture is designed as the bridge, essentially, between these data streams and your operational needs in RCA. So it gathers and harmonizes this complex data, processing it into a format that not only supports our RCA workflows, but also works to enhance and constantly improve them. So imagine an engine that takes in all of the unstructured data and outputs a streamlined visual roadmap to your RCA, complete with the dashboards, report checklists, analysis, and collaborative workspaces, so your teams can quickly move from problem detection to resolution. So this architecture is the key to this architecture is its integration with your existing systems, right? It ensures that every piece of data, whether from a legacy system or a modern sensor network, is leveraged to deliver one key outcome: a clear and confident RCA report before your unit is back online. So this isn't just about fixing issues. It's about establishing a proactive, informed approach that instead focuses on preventing reoccurrence and minimizing your downtime. So it's not intended, this RCA engine is not intended to just be an add-on to your existing incident management system. It really should be the heartbeat that powers every step of your RCA process, working to turn as much data, complex data, into actionable insights and analysis.
Thanks, Aaron. Fantastic architecture. And I call it a wrapper. I hope that's not offensive, but I think it sits on top and it can really drive everything that you have in getting to that root cause to make your plant have higher uptime than it ever had before. So I like it that it's unobtrusive and yet it's so informative to help the folks run the plant better. With that, I'd like to open it up to a polling question. And what are the capabilities you would like to see in an online root cause failure analysis tool? Looks like we have a couple requests here. We'll be coming back to this polling question at the end. Again, you can join the polling at pollev.com/Jim DeVries 073 to join the poll, and make sure you put us underscore between phrases. Otherwise, the words will come out individually. So it looks like we already have some additional ones here. Brainstorming causes is a good one. RCA project stat tracking. I think, Aaron, you've covered that already.
Yep.
There we
Yep.
go.
That's a huge focus for our countermeasures development module, which will be coming out later this year. I'm also seeing workforce sentiment. That is available today through our polling feature. Really, the idea behind that, it's not necessarily the same approach that we might see an HR department rolling out kind of a sentiment study. This is really trying to gauge the sentiment of your different teams and subject matter experts as they contribute to the RCA.
We'll keep those comments rolling. As soon as every time I say it, there's a new one that pops in.
I love building a complex Y tree. That's really the hope of kind of the AI powered Y tree builder. Essentially, the idea is that it has context on a ton of different data sources that it's identified as relevant to that root cause, and it will essentially guess multiple branches of that Y tree as you build it out, and then it's got access to more data than we as a person could process at any given time, but we need the human touch. So that really is going, no, that doesn't make sense. That does make sense. Let's start another branch off of that. And I think that once we roll that out fully, I'm super excited to see that tool in use.
You see ERP connections.
Yep, that is doable today with our enterprise offering. Your ERP system, data historians. I'll get into how we scale later in the presentation. But really in the beginning, that pilot might be identifying like what that most important one connection is and just running with that, and then expanding to more as we scale.
And I think there's a link to quality performance of the product that's being made, I think is what they're getting at.
There absolutely is a huge part of our potential customer base is, it's quality, it's safety, it's operations for chemicals, manufacturing, utilities. That's really where we've based our RCA structure around.
These are great comments. Let's hold off a bit. Fantastic comments. Thanks everyone for commenting. We'll re-engage in this. So please keep entering. Will be the drum roll to see what happens towards the end of the 3 case studies. So with that, we'll get into the first case study, a generic turbine generator trip, which is since I'm a turbine generator engineer, this is close to my heart. So I'm going to at least pose the problem here that happened where the client experienced a generator winding failure, and that's the stator of the turbine generator set, and they didn't address the root cause correctly, and then they had to a forced outage 1 month after they thought they fixed it the first time. Why? Because they said, oh, there's water, there's moisture in there. Well, in stators, there's water. water-cooled windings. So they detected moisture leaking through the insulation and later discovered the insulation deterioration and outdated materials. This is a very common problem in stator windings in turbine generator sets that are oscillating in power. In this particular case, they oscillated between 70 and 82 megawatts constantly. And that sooner or later, that caught up with the stator and caused the deterioration of the windings, which caused the moisture, the leakage. But the actual root cause is the way that the turbine was being operated was not the way it was designed. It wasn't designed for cycling between 70 and 80 megawatts constantly. And so it's through that root cause analysis that they were able to determine the second time. But if they had done this right the first time and spent the time, they could have avoided that, a lot of that loss. That's about $333,000 a day for an 80 megawatt turbine. That's about the average at that particular time when this incident occurred. That's pretty much the typical losses of generating power for the grid. So that's the example, and you can see in the bottom left, that's what a winding damage, stator winding damage looks like. And then we have just a look at what it looks like for a stator rewind and the guys in there finishing up that generator. With that, I'll turn it over to Aaron for the case study on how this would look like in his tool. Aaron?
All right. So welcome to our main workspace. Here you can see all of the ongoing investigations, each one represented as a board in our system. Notice the meeting readiness index on each board overlaid on top of it. This is intended to give a quick visual snapshot of how prepared we are for each RCA session. So now we're going to start a brand new board for our generator trip event. So let's jump right in and set up the foundational details. So as soon as we create this new board, the system prompt helps us to fill in key details for our RCA. First, we add a summary timeline. This helps our team see at a glance the sequence of events leading up to and after the generator trip. Next, we are going to specify which KPIs were impacted and link to any relevant data sources like performance logs or environmental reports to give our AI engine a solid data foundation. This is one of those things where the quality of your data going in will reflect the quality of your analysis coming out. So here we're putting in just basic KPI and data impacted. We have a little bit more included, a little bit more detail included in that timeline that we just put in there. So if you put in a high level KPI like this, it really does help the system kind of identify it to business needs for an executive stakeholder. So then we want to identify who needs to be on this team. It's crucial to involve the right stakeholders, right? Maintenance leads, process engineers, anyone else with critical knowledge of the operation, subject matter experts like a turbine expert is absolutely critical for running a root cause analysis session on a turbine or generator failure, right? And that seems obvious, but I've certainly seen many RCAs get set out where it's like, oh no, they're busy because of the downtime and they can't be involved in the RCA, right? And that's not going to provide a quality RCA, right? You're not going to get to the right root causes. So by assigning them to this board, we ensure that they'll have instant access to all findings and action items, which again, really helps with the communication, especially asynchronously. And then finally, we define our problem statement. Think of that as kind of the North Star for this RCA. So now here's where things get exciting. So after we've input our data and the team's initial insights, the system runs multiple AI workflows to predict potential failure points. You can see on the right here, it's flagged 5 likely root causes, failure points, or causal or contributing factors based on the historical data, diagnostic reports, and the fishbone trigger diagrams we've included. So one of these stands out, the contaminants on the insulators. So this was the missing link in our first investigation, not a root cause, but a factor that degraded the dielectric properties of the winding, ultimately leading to the second failure a month later. So our AI-driven analysis also suggests some broader root causes related to business processes that might have allowed these contaminants to go unchecked. Now, our system was not able to go deep enough to identify the things like the business decision that ultimately led to the root cause that Jim had mentioned previously. But keep in mind, these organizational insights become more precise as we tailor these systems to your specific equipment and operational context. So, our third case study, the cybersecurity one, will really focus even more so on the power of improving these root cause or causal factor prediction models. Even so, it's still a powerful example of how structured data-driven workflows like this can help uncover critical issues that might otherwise slip through the cracks, especially when you're facing costly downtime, and then actually end up saving you from repeated downtime and those costly surprises.
So Aaron, we have a question. Do you need a specific format for the team members for them to get reports, et cetera, automatically?
Yeah, so right now for like the generic version does have sharing with team members, like the self-service version. Right now it's just put in their email, and it'll send them an invite to join the session. We take a little bit more robust approach with the enterprise version. We spend a lot of time looking at your organizational hierarchy and deciding essentially who should see what, who should be involved with what, and when people should see what. You know, as we're trying to like brainstorm potential causes, you probably don't want, right, like your CEO to see as you're guessing ideas, right? That's not conducive to a productive problem solving event. But you certainly want them to be aware of the event and that it might impact the P&L as soon as possible. And what are some of the things you're going to do about it immediately? So like that information would go to the CEO, but maybe shouldn't go down to the floor level operators, right? So at an enterprise level, we take more of a hierarchical approach like that. But great question. For the self-service, it's just put in their email, and it sends them an invite.
Excellent. So that brings us to the second use case on a highly toxic materials or fire from spill. And Irene will kick us off here.
Thank you. So this process safety incident case is from the CSB report on the ExxonMobil's Torrance refinery. The explosion had occurred in the ESP and it ignited hydrocarbons, nearly impacted some adjacent hydrofluoric acid tanks and exposed several severe safety failures. This near miss event risked catastrophic HF acid release. And so one of the things you want to do is make sure it's easy to leave no stone unturned. Now, what you can see here is a very simplified, for the sake of this presentation, Y tree on the explosion. And so if you think about it, what are some of the key root causes? There was indirect operating parameters failed to detect the dangerous conditions. So there was inadequate process safety management. There was erosion damage and a heating leak exchanger that compromised the equipment integrity. And so that points to your maintenance and inspection procedures. There was a failure to shut down the FCC unit when the other unit leaked. And so you got to take a look deeper into your operational and shutdown procedures. There was a reliance on outdated variants without revalidation. This is where you have to take a look at your change management and your variance management systems. And then finally, the expander was not isolated and the energized ESP provided an ignition source. There was inadequate design and integration for the equipment in this process. It gets a lot deeper than this, but we're providing that high level summary for the analysis. So now with that, Aaron's going to talk about how this was analyzed in his tool.
Thank you, Irene. So we start with an animation from the Chemical Safety Board illustrating how a hydrocarbon mixture leaked past a failed gate valve after the catalyst had all fallen out and flowed into the electrostatic precipitator. The result, as Irene talked about, a sudden violent explosion that could have been even more catastrophic if the nearby hydrofluoric acid tanks had been compromised. This visual is going to set the stage for why a thorough data-driven RCA is so crucial. So let's transition into our enroute.io dashboard. Here we again see our meeting readiness index for each investigation, providing a quick overview of how prepared we are before diving into the RCA session. So we will open the board for this particular incident where we've already outlined a lot of the key details that we discussed about on the last case study, a summary timeline that pinpoints the sequence of events. Here, February 18th, 2015, an explosion occurred. That's our problem statement. The KPI metrics impacted, such as safety and production losses, along with the relevant data sources like the assigned team members, and again, the clear, concise problem statement. The clearer the problem statement, right, the better we direct it and scope our RCA. I can't tell you how many times I've seen a team not be aligned on the problem statement and that cause issues later on with alignment on the RCA. So notice the chat feature in each RCA task right above add another comment here. Let's focus on the problems. This is in all of the tasks, but let's focus specifically on what we use that for in the problem statement section. This is where our team shares insights, add tips to refine the statement, and drops recommendations for the facilitator. In our next phase, and if you're at the enterprise level, we can offer this today, we're going to replace that with an AI chatbot that behaves like a Lean Six Sigma black belt, guiding you through a proper RCA process. So moving on to the AI outputs that truly elevate our analysis. First, we have the data collection plan. After a major incident, gathering all relevant information can take weeks, especially in a complex and impactful operation like this incident was. Since we don't have access to the refinery's actual data, this plan is an initial recommendation of what to go out and collect. And as more details come in, you simply rerun the workflow and iterate, and the AI will refine its suggestions, highlighting additional data to go after that could be more pivotal. And next, this is an example of a trigger diagram, which is essentially a starting point for a fishbone or Ishikawa analysis. Of course, we can put it into whatever format your team needs it in. I like to have it laid out like this, just because I then transfer it to a board somewhere to share with my team. Now, this helps map out potential causes across categories like equipment, environment, and human factors. And as we learn more, each branch can expand, ensuring how multiple contributing factors interact rather than chasing a single smoking gun. And on that note, I would like to hand it off to Irene. Irene, I recall you mentioning a client who had insisted on a purely linear Y tree instead of going the broad approach. Would you like to share on how a broader approach provides a better view of interacting factors and ultimately leads to a better root cause analysis session?
Yes, so I'm smiling because I remember this conversation. We were running an incident investigation, and one of the leaders, was trained in the fact that you ask 5 whys, and that's it. And it's a why stick versus a why tree. And I was trying to gently explain that if you only focus on the stick, you're missing a lot of the side branches that lead to really critical root causes. So you have to think not just linearly, but you got to think a little bit outside the box for all the possible causes and not just the singular event. So I want to challenge folks when they're using these tools and in their RCAs is don't just think very linearly, think of multiple reasons. It should be a Y tree. For complex ones, it's going to be a tangled Y tree. But you're going to drive down into the root causes and the possible contributing factors, and that will really help prevent this situation from occurring again. Thank you.
Thank you.
With that, we head for our third application, cybersecurity. I love it that we're doing 3 completely different type of applications showing the robustness of the tool. Aaron?
Thank you, Jim. So a trend that I've seen with a lot of emerging technologies and different strategies to solving age-old problems is that big tech or a startup in Silicon Valley will essentially solve solve a problem as an engineering tool for software engineers in a totally new way, specifically for their strictly digital systems. And then if you look down the road a couple of years, we'll see that same strategy applied more broadly to physical systems. So this, I think, is going to follow that trend, and I'm already starting to see it applied in industry. And this is really what I see as the future for root cause analysis. So let's take a look at how big tech is tackling root cause analysis at scale today, and specifically at the company Meta, where a massive monolithic code base undergoes constant daily changes. They have thousands and thousands of new code pushes to production, which is a very unusual, a very unique situation, I'll say. So when something goes wrong in a code base that large with that many constant changing parts, pinpointing the root cause can feel like searching for a needle in a haystack. But Meta has an AI-assisted approach that combines heuristic-based retrieval with LLM-powered ranking. And the LLM-powered ranking runs through a machine learning algorithm on its own. If you're curious on any details like that, please feel free to shoot me an email or a DM on LinkedIn. I'd be happy to go into how this can be built further. So first, the system filters thousands of possible changes down to a more manageable subset using heuristics, which basically means filters. This is things like properties like code ownership, runtime logs, and usage data. So then they start with this huge amount of data and then they shrink it down. And then an LLM, in this case, Llama 2. So keep in mind that's an older model now. These statistics are, I wouldn't be surprised if they were already running at a much better rate. So it ranks those top suspects to identify the most likely culprits. In practice, that means about a 42% accuracy rate in pinpointing the root cause right out of the gate as soon as the incident occurs, which significantly cuts down on the mean time to resolution and keeps their platform running smoothly. What's exciting is that this same principle using AI to sift through vast amounts of data and then to zero in on the most probable failure points can be applied well beyond software. Whether it's a refinery process, a manufacturing line, or a cybersecurity event, the idea is to harness all of this data and process it using machine learning or AI techniques to accelerate and improve root cause analysis, and in this case, specific root cause identification. And that's exactly where we're headed next. So we'll explore a cybersecurity incident in a manufacturing setting to show how a similar AI-driven workflow can quickly isolate the root cause. This is the future of incident resolution, bridging the gap between what we see in big tech today and the broader industrial world. So welcome back to our enroute.io board. This is for a cybersecurity incident scenario at a manufacturing site. Here you can see all the tasks laid out, again in Kanban style, each step representing a stage in our RCA process. We've already populated the key details like the timeline leading up to the incident, impacted KPIs like detection and containment times, and our core problem statement on potential misconfigurations and undocumented changes. So we've assigned roles from the incident commander to the human factor specialist to ensure we capture both technical and human elements here. And this is gonna mirror the data-driven AI-assisted approach that I just described at Meta, gathering as much context as possible up front to pave the way for faster, more accurate root cause identification. And the way I'm going to show a tie from how they identified root causes instantly at Meta with just LLMs, where all of the data is digitized, is in these physical systems, that human perspective, having a human in the feedback loop with your large language models is critical. That's the gap to getting those models to work in a physical system. So I'm going to demonstrate enroute.io's polling feature here. I'm putting in my my email uh, where we're going to invite one of our on-site operators to submit observations on recent network anomalies, like unrecorded firewall changes or odd ICS error messages. Their responses update our Kanban board in real time, signaling fresh input for the facilitator and showing the progress of each of those polls they've sent out. So here I've laid out essentially all of the answers ahead of time, answering the questions: who should be on the team, what did you observe, subject matter expert, and what do you think the problem is, right? You can see how getting these different perspectives up front from the actual technical experts really helps a facilitator scope the problem well. Is also feeds our LLM prediction systems with that missing insights that it did not have, because a lot of that data lives out in the physical world with us as operators, as leadership, as the people that work on these systems. So once the poll is complete, the facilitator can finalize notes and click generate report, instantly consolidating the entire RCA, including all of these new insights that it's gathered. So this is a glimpse of kind of what automated RCA looks like, where real-time data collection and integration accelerate the path to incident resolution. So here is where our AI-powered analysis comes into play. On the right, we see sentiment analysis. On the poll responses, flagging any communication breakdowns or manual overrides that weren't logged. It then prioritizes potential root causes or causal or contributing factors, depending on how much information it has, from altered firewall configurations to undocumented ICS changes. So this shows kind of how heuristic filtering, or those predefined filter rules, can really help narrow down to what truly matters, while also allowing us to have a really broad data set underneath of what your system is looking at as potential causes. So this approach not only speeds up your RCA, but it also aligns with what we just saw with Meta's AI-driven strategy, kind of proving that even in these complex physical systems, machine learning can still rapidly surface the most probable culprits. And we're already seeing how these advanced methods reduce mean time to repair and offer real-time anomaly detection, whether you're in cybersecurity, cybersecurity at manufacturing, or utilities and energy, right? Now, one quick thing I want to point before we step away from this is the actionable points for RCA facilitation. If you read through those, review and audit network and firewall configurations for undocumented changes, right? That's something we normally hand off to somebody. Like, you might hand that off to somebody in IT. But this is where agentic systems come in. You can, and this is going to progress very, very quickly. Like what we say today, absolutely, you could not give that to an AI agent. Very likely in a couple of months, it's like, yeah, you could probably give that goal to an AI agent and they would do a good job. Um, and this is a great example. Review and audit network and firewall configurations for undocumented changes. You could hand that tool off to an AI agent. And instead of just having that as an actionable point for RCA facilitation, it could hand that list of changes and undocumented changes already ready to be reviewed by that subject matter expert. So with that, I will jump into essentially connecting the dots. This is our final takeaway for how these methods, automated RCA, heuristic filtering, AI-powered analysis, ultimately transform the way that we handle incidents. So here are a couple of the key lessons from our third case study. And I know it's a lot, and it's new technology that we are not used to seeing in the industrial world. Automated RCA. So we've seen how real-time anomaly detection and incident monitoring can significantly speed up problem identification, saving critical time when every minute counts, right? If you have a major incident, if a unit goes down, right, that's when our focus matters most. Heuristic filtering. So this is our secret sauce, essentially, to processing huge amounts of data in every single RCA. So by applying predefined rules, we can narrow down to root causes efficiently, cutting through a lot of the noise and focusing on what really matters. This also saves us significant compute power, right? So this allowed us to include very large databases that we've spent a lot of time up front building, and include them in these analysis to provide additional context. And then AI-powered analysis, right? So Specifically, I want to talk about how we combine machine learning with multiple LLMs. You could call the process that we used of multiple LLMs speaking to each other, one in charge, one checking the work of the others, one being specific for your FCC unit RCAs, one being specific for your IT department RCAs. Combining all these LLMs together with a well thought out learning algorithm takes it a step further. So ranking the most probable causes that when you get that system accurate for your system and for your business truly accelerates resolution and ensures that we tackle the biggest issues right away. So seamless integration, I'll end with this. Perhaps most importantly, this workflow plugged right into the existing monitoring and alerting tools, minimizing disruption while maximizing the amount of data-driven insights that we had while we were actually solving the problem. And then we really tailored what Meta did for their code system, and by using human feedback, we're able to prove its effectiveness even in physical system environments, even complex ones like cybersecurity, where you have code changes and then you also have physical stuff on the ground, right? Um, and then looking forward, so as the AI industry continues to advance at alarming rates, RCA is only going to get more accurate and faster, dramatically reducing mean time to repair and our ability to identify a lot of these issues up front. So organizations that embrace AI-driven RCA are ultimately going to benefit from quicker resolutions, fewer operational disruptions, and a stronger, more resilient system overall. So with that, I will close out our final case study on the transformative impact that you can have on root cause analysis using AI and machine learning. And then we will change gears to the business approach.
So we're back to the polling question, and we got some pretty good comments here. And we did slot this for 90 minutes, but just to make sure we've covered everything. Is there anything new you want to cover on this, Aaron, on this particular slide?
Yeah, I will say the causal tree linked to data and opinion, um, that is really what the end product looks like for that root cause identification, right? Like you can imagine how, and Meta actually talks about this in their approach, the problem of a machine that without any context or sources blindly spits out, hey, this is a potential root cause, a root cause, and totally skipping the causal factors, the things that you observed out in the field, and the contributing factors that might have led you to that conclusion organically. So the key really is that putting it in a format that we're familiar with in that problem solving, like a causal tree, and then linking it to the data and opinion so you can follow what your system actually thought through and what data it looked at to draw those conclusions, right? Making sure it's vettable. Putting in probabilities is super important. You can't just say, hey, here are the top 5 things I think were the potential root causes for your problem. You instead have to say, hey, we didn't have enough data. We weren't 95% confident on anything. Or, hey, here's 2. We're 97%, we're 96%, and we're 93% confident that these are actual root causes in your business. So tying all of this stuff back to data and opinion and making sure that it's sourceable, you can go look at the original sources is super critical to building systems like this.
So we do have a question in the chat, and actually 2 questions in the chat. I see how does the system prioritize the different root causes? Are you using any analysis functions in the tool itself, or are you looking for people to do that outside the tool?
Yeah, no. So in the generic self-service version today, so like if you went on my website, that first module that we have live on our website, that piece does not have that advanced feature. But in the enterprise package, and I specify that it's with the enterprise package today because you need to build and check those systems custom to things like what does your P&ID look like at your plant? What is your organizational hierarchy? What types of physical pieces of equipment do you have on site? What does the OEM look like? We need all of that information um, to build that analogous system. So in the enterprise version, yes, 100%. It's grounded in data analysis from what you typically think of, right? Like a data historian type of thing, the information you would pull from a data historian, but also things like your polling, what your facilitator and your RCA team put together as a problem statement and as the affected KPI and the timeline, right? Like that's not traditional data, but that is also
Yeah, I
included.
think they're asking if it generates a Y as a function of X equation on root
Uh,
cause with coefficients and equations and interactions. I think
so
that's what we're getting
we
at.
do have that capability today. Yes.
Okay. And then another one is once you do get to root cause, do you have plans for a aligned corrective action tracking
Yes.
program for each of the root causes and brainstorming activities to generate innovative solutions? Is that something in the future
Yes.
plan?
Yep. That is a future phase. If that is a critical piece for your organization, we can absolutely accelerate it into the launch plan that we'll go over on the next slide. So yeah, we have essentially rough drafts of that today. It's harder to make it generic and self-service than it is to make it specific and customize it for your organization. So that is possible very quickly within your organization.
So that probably leads perfectly into the next section on how to launch with impact and your launch roadmap.
It does. Thank you, Jim. So earlier we mentioned that only 11% of AI solutions successfully scaled in 2024. And I picked up this statistic on the McKinsey World Economic Forum Davos webinar, and it instantly stuck out to me. So our roadmap here is the secret sauce for making sure that you're part of that 11%. And if RCA or incident management is not what you're interested in applying AI to, feel free to steal this. It really is an excellent way to tie AI to real business problems and focus on a specific business silo while doing that. So let me walk you through the 5 phases we use to launch enroute.io across your enterprise. So phase 1, this is our strategy and readiness. This takes about 4 weeks. So first, we align AI objectives with your business goals and problems, assess current RCA challenges, and secure leadership buy-in. This will help set a strong foundation and ensure that everybody's on board with our approach. And that this is also where we ensure we are not just using AI, again, for the sake of using it, which I have seen plenty of times in 2024, but actually using it to solve real business problems. And that brings me to my next phase, phase 2, which is weeks 5 through 8. This is where we map out your data integration strategy, your ERP system, configure the AI models, and align all of these workflows to your specific business processes. So this is where we ensure that enroute.io's UI and system fits seamlessly into all of your existing business processes. And then deployment and testing, this is weeks 9 through 12. Here's where the real world validation happens. We run a pilot deployment, measure accuracy and performance, and then train your team for smooth adoption. And then finally, optimization and scaling. This is weeks 13 through 20. So once we've proven the pilot to all of the key stakeholders, we then refine our AI models and roll them out more broadly and track the business impact, making sure that you see clear ROI. And then phase 5, this is ongoing. This never stops. Continuous improvement and innovation. We keep evolving. AI is a quickly moving industry, right? We were talking about ChatGPT a year ago. We're talking about agents this year. There's a lot of noise in the industry, but it is moving quickly. Enhancing your AI capabilities, automating preventative actions, and benchmarking against industry leaders continuously is the key to staying ahead of the curve here. So following this roadmap will not only accelerate your RCA, but it will also reduce your mean time to resolution or repair, for your incidents and help you build a resilient AI-powered incident management system. In other words, we're not just working to implement AI into RCA. We're working to scale it and successfully drive real measurable value for your business using RCA.
Sweet. With that, I'm just going to close it out with the financial impact opportunities. Of course, the most important is loss of life and avoid injuries. We want to see a reduction of that by 40%. And then it gets into workday cases and restricted workday, restricting those and the loss of those. And we can do that by 30%. And then you get into unplanned shutdowns, which could be anywhere from $33,000, $300,000 per day on up, depending on the size of the facility. And of course, by implementing this and having a robust RCA program, your insurance costs will be reduced by up to 25%. Of course, your medical cost coverage would also be reduced, and the additional equipment repair is also going to be reduced by 10 to 40%. And then, of course, because you're running more efficiently, your material costs are going to go down. You're going to have less labor relations challenges, and your productivity is going to be better because you're going to have a happier workplace. And then that's going to spill over to your community relationships. And then, of course, the regulatory fines and right to operate and non-compliance issues, you can reduce those significantly up to 50%. So those are some of the reasons why you want to go down this path of using AI and RCA, because we all have to do more with less. And now you're having the AI agents and the agentic and all the latest AI companion helping you and your team get better and better every day. So in conclusion here, we hope we addressed the deliverables here of addressing the challenges applying AI. We looked at the architecture Aaron has laid out in enroute.io. We went through 3 demos of how his tool works, very in detailed. He gave you a technology roadmap. And then, of course, we showed how it can integrate seamlessly into your facilities. So with that, we thank you for your participation in today's webinar. And of course, we want to create that environment that, that unplanned downtime is a deeper issue that you're overlooking. So what is that deeper issue that you're overlooking? Let's get proactive about it, and let's drive your productivity to a higher level in a safe environment. With that, we do look to have some additional webinars on how enroute.io integrates with some of our other partners, Ferrell Labs and DuPont Sustainable Solutions, and gaining insights on how together the 1 + 1 = 3 to drive productivity into your workplace. With that, I will turn it over to Irene first for any closing comments.
Thank you. So this is really exciting for me because as an old school type person who's had to suffer through very lengthy RCAs, hurting the wildcats of multiple opinions in the room, detangling the data analysis, having tools like this to expedite the process, gather the human input, and really streamline the whole thing is something that I wish, Aaron, why didn't you invent this like 15 years ago when I needed it? So I'm really excited to see this tool launch and to see the possibilities that it grows. So thank you for keeping me in the loop and including me on this journey with you.
Aaron?
Thank you. And thank you, Jim and Irene, for joining me on this webinar. Your insights are incredibly valuable to really making sure that we're solving the real problems that everybody in industry is experiencing with RCA. So before we wrap up, I want to thank everybody for investing your time and energy into this session. Your willingness to explore new approaches to incident management is what drives innovation and lasting change. So we've shown today how AI-powered RCA can reduce mean time to resolution, improve your team's collaboration, and overall foster a culture of continuous improvement. But remember, success is not just about the cool software tools that your organization buys for you. It's about having the right strategy and alignment across your teams. So if you're ready to take the next step and see how Enroute.io could fit into your organization's unique needs, let's keep the conversation going. We'd be thrilled to discuss how we can help you accelerate RCA, enhance resilience, and ultimately transform the way you manage incidents. Thank you again, everybody, for joining us, and we look forward to partnering with you on this journey.
Thanks, Aaron, and for bringing this to us, and Irene for adding the color and the real life situations, and all of you for joining us for this hour and a half. And we hope that you found it engaging and interesting. I'm very excited about this because this is right up the ethos of Enhance International Group, which is people, process, data, technology, and using AI to enable that and be the conduit so that we're developing solutions that are going to last. So thank you again and have a great day.